Okay, we are picking back up in lesson 1.2 where we left off yesterday. When we left off yesterday, we talked about functions, right? We were talking about how to know whether something is a function or not. X's cannot repeat, has to pass the vertical line test, right? Okay, those were the big things we were talking about, whether or not it was a function. And we were just starting to talk about domain in this class, weren't we? Okay, so example 3. We were looking at 3a, and it says find the domain of each of these functions. Domain, if you recall, refers to x values, right? So we want to know what kind of x values work in this equation. And when we talked up above, there were two big things we have to watch out for, right? We have to watch out for square roots, because square roots can never be negative. And we have to watch out for denominators, because denominators can never equal 0. As we looked at a, we had a square root. And what did I just say about square roots? Square roots have to be positive. They have to be positive, right? And so when I say positive, mathematically we can say, okay, it has to be greater than or equal to 0. And that's what we did right here, is we set x plus 3 greater than or equal to 0. Now, can you solve that? If it's x plus 3, what are we going to do?
Subtract 3.
We're going to subtract 3. And so then we end up with x greater than or equal to negative 3. Okay, and this was all because it's a square root. So because it was a square root, we had to do the greater than or equal to 0 part. Okay? Now, think about it. Numbers greater than or equal to negative 3. So if I put negative 3 in here, negative 3 plus 3 is 0. And we can do a square root of 0, right? Just 0. If we put in negative 2, negative 2 plus 3 is 1. Can we do the square root of 1? Yeah. If we put in negative 1, negative 1 plus 3 is 2. Can we do the square root of 2? Yeah, it's a decimal, but we can do it, right? And if we keep going up, there's always numbers we can put in. If we go back the other way, so this just says greater than or equal to negative 3. Does this make sense? Well, what if we put in negative 4? Negative 4 plus 3 is negative 1. Can we do the square root of negative 1? Not in real numbers, right? And that's what we're focused on right now. We're not talking i's, we're not talking imaginaries, we're just talking real numbers. So right there, that is actually your domain of this problem. X is greater than or equal to negative 3 because it's x values that are larger than negative 3. Now, the equation helps on this one. However, I want you guys to also be able to look at a graph. So if you would, please graph this. Okay, which, remember, what is f of x the same as? That's a y, right? So this is really y equals the square root of x plus 3. We're not doing anything fancy with the calculators today, but, you know. So if I graph, everyone knows how to find their square root, right? It's a second of my x squared button, and then I type in x plus 3 under it. I'm going to do a zoom 6 because, you know, I never know what I last graphed. Okay, that made the glare worse, so we'll turn that light back off. Does your graph look like my graph? I mean, that's half the battle, right? Hopefully by this point you can do a basic graph like that. Now, if we hadn't done the algebra, because to me what we just did is we did algebra here, right? We set whatever was under the square root greater than or equal to 0. That told me, okay, x greater than or equal to negative 3. Well, as we look at that, does that make sense? Okay, so how do x values run? X values run from where? Left to right? Okay, so if x values run from left to right, notice, where does my graph start at? And we can even do trace to help us out. And if I trace over here, it's not going to be precise, but notice about where does it look like my graph starts at? Notice if I go past -3, my y value doesn't exist. If I'm to the right of -3, my y value exists, right? So does that make sense that my graph starts at -3? And then what happens? Does it exist all the way over here? It does, doesn't it? Because this is like half of a sideways parabola. And so my graph exists over here. And so this is my domain. My graph exists anytime x is greater than or equal to -3. Okay? If you didn't have the equation here, you could still get the domain because you're just looking from x values. So as I start at the left, at what x value does my graph begin? And it begins at an x value of -3, and it keeps going off the screen. Okay? So what is this in interval notation? If my graph starts at where? Starts at -3. And how far do we go in the x values? Infinity, right? So in interval notation, this is -3 to infinity. Bracket or parenthesis on -3. Bracket. Because can -3 be included? Yes, -3 plus 3 is 0, square root of 0, that can be included. And then infinities always use parentheses. Okay, so a couple of things. First of all, when it says find the domain of each of these functions, realize that we are looking at x values as we travel from left to right. Okay, x values as we travel from left to right across the screen, okay, or across the graph. Now, if I put I'm going to put a little picture here, because I think pictures are helpful. And if we put a little picture here, our graph went -3 over this way, right? So you're thinking about, okay, when do these x values exist? Okay, what x values are we using? And we're using from -3 right over here. So this is kind of the graph connection. And I'll be honest, as we get into this, some of you guys will like looking at the graph better than you like doing the algebra. But I like to go for between the two. I like kind of to look at a combination of, okay, the graph and the algebra together. Because the algebra tells me I have to use the number 3 somehow. Ended up being -3 when we solved it. Okay? So that's how we ended up with the x greater than or equal to -3. Questions I can answer there to explain things better. We either got it or we don't got it, but we don't know what questions to ask. Is that we're one place or the other probably? Or we think we have it, but we're not sure, but we don't know enough to know. Okay, let's try B. Okay. B gets a little crazier, doesn't it? Yeah. Of course. We got to start you off easy, and then we'll work you up. That's what's happening here. Okay. So B, f of x. Gosh, this is all kinds of typos. This should say f of x equals, and it was kind of changed as you can tell, x, the square root of x over x squared minus 25. Now, up higher in the notes, and I've mentioned it verbally today, what kind of things do we need to look for as we're thinking about domain? Like if I don't look at the graph yet, what kind of things do we need to look for? What do we consider on the last one? There was a square root, yes? What do we say has to be true about a square root?
Has to be positive.
Has to be positive. So in this case, what's under the square root? X. So we know that x, whatever's under the square root, has to be greater than or equal to 0. So right there, I just eliminated half of our numbers. X has to be positive. When we graph this, we should not see anything to the left of the y-axis because X has to be positive. Does that make sense? Now, besides square roots, what's the other thing I said we had to watch out for? Denominators. Denominators cannot what? Equal 0. So, if a denominator cannot equal 0, what I'm going to do is I'm going to set my denominator equal to 0 to see what those values are. So, we're going to set x squared minus 25 equal to 0 with the idea of when we solve this, whatever answers we get, those are places that x cannot be. Okay? Because it's kind of the idea of, okay, x squared minus 25 cannot equal 0. That's what we're thinking. How do we solve this? If it's x squared minus 25, I'm going to add 25 over, right? If x squared equals 25, how do I solve?
Take the square root of both sides.
Okay, we're going to take the square root of both sides. The square root of x squared is x. What's the square root of 25? In an equation setting, what is the square root of 25? Plus or minus 5. Every time, as soon as I say that, you guys know. Okay, so we always have to consider the positive and negative roots. So I'm going to say x equals plus or minus 5, which really what this means is x cannot equal positive 5 and negative 5. Okay, so these are the two pieces we have right now. We know x has to be greater than or equal to 0. And we know x cannot equal positive 5 or negative 5. Okay. And again, I'm holding off looking at the graph. We'll look at the graph and use that to help make sense here in a moment. Think on a number line. Okay. On my number line, I'm going to put a negative 5, I'm going to put a 0, and I'm going to put a 5. I'm trying to do a visual here to use a number line to help us. Okay, what do we know?
X is greater than 0.
Okay, x is greater than or equal to 0, which means what? This stuff back here? None of that, right? Because x has to be greater than or equal to 0. What else do we know? It can't be, officially, it can't be 5, and it can't be negative 5 officially. Does the negative 5 really matter at this point? No, negative 5 is already not allowed because it's smaller than 0. Huh? Okay, so it has to be 1, 2, 3, or 4 or higher than 5. Somewhat. Now, when she says that, what's she leaving out when she says it has to be 1, 2, 3, 4 or higher than 5? Is it just 1, 2, 3, 4 down there?
0.
0. And can we include decimals in between and stuff if I want to get, Okay. So the idea here is, if we think about shading, right? Okay, it can go all the way down to 0. Is 0 included? Yes, because it was greater than or equal to 0. So I'm going to think bracket. Now, what happens at 5? Is 5 included? No. So I'm going to think, okay, it's kind of like there's parentheses at 5. I put in an open circle, which takes you back to your algebra days, right? But it's like there's an open circle one way on 5, and what about on the other side of 5? There's an open circle there. And then that's going to go off to infinity. Does that make sense what I did? Can you write that in interval notation for me? Where is the first interval start at that my domain can exist? We can start at 0, yes. 0 with a bracket. And then that shading goes up to 5, because because we have to take a break at 5, right? Because 5 is not included. 5 is going to have a parenthesis. And then we're going to have another interval, yes? So what do I use to connect those intervals? U for union. And then the other interval is going to start at 5 and go to infinity. Notice both places on 5 I used parentheses, didn't I? Because it's 5 included. No, 5 is going to make that denominator equal to 0, which is a big no-no. Okay, let's graph this. Just because I want you to try and see the connection. Because there's sometimes the algebra is not as easy. So if I graph this, I'm going to do a fraction. Square root of x divided by x squared minus 25. If you can't do a fraction, or if you opt not to do a fraction, x squared minus 25 needs to be in parentheses. And if your calculator can't do a fraction, you might see me later because I've figured out how to update some of the calculators so they can do fractions. So.
Yeah, I don't know. Ethan was very happy about it.
Huh?
Ethan was very happy about it.
I got 2 of my calculus kids updated. That's after a year. And then I also got a pre-cal kid updated. So, but yeah, so I would totally encourage if you can do the fraction, which my shortcut is alpha F1, remember, right? All of the CEs, the color additions, they can definitely do fractions. If not, you just don't know how. Okay? But if you don't do a fraction, put x squared minus 25 in parentheses, right? This thing's weird? And mine looks... stupid glare. Let me update yours later. We might be able to get some new fractions. But so square root of x, right? Divided by, and then we're going to do parentheses. X squared minus 25. I have a lot more experience. I'm going to do Zoom 6 because I have no idea what you graphed last. Yeah, that's hard. That's what it looks like, but yeah. Now, and this is where the better graphics make it look a little bit better, yes? Could you zoom in if you want to see it a little bit better? You can. And in fact, I'm going to do the window, and I'm going to change, I don't need to see left of 0. Well, I'm just trying to get it zoomed in better, so I changed some of my settings. Okay. What I did there is I changed, first of all, I took my x min to -1. I don't need to see all that over there, right? And I changed my y min and max to -5 and +5, so it's kind of zoomed in. You could also try and do a zoom in to kind of see. But, okay, think about this. What's happening there? Do you know what's happening there at 5? We would have talked about these in Algebra 2. Remember something called an asymptote? Asymptote? An asymptote happens when the denominator equals 0. And so what happened right here is my denominator equaled 0, right? There's a break in the graph. And when we draw asymptotes on paper, we draw them as a dotted line, right? And what's happening is this is running down alongside 5. This is running up alongside the right side of 5. But if we do trace, okay, guys, it's all about what values? We're talking domain, so it's all about the x values, right? So if I trace all the way over to the left, notice, okay, 0, 0, it shows my graph existing. What happens when I go left of 0, when I hit negative x values? My y does not exist. So what's that saying? My graph does not exist. So over there where x is negative, my graph does not exist. So does it make sense then, or that's why our domain starts at 0. Okay? So I get up here to 0, 0, and then as you trace, watch my x values, right? I have 1, 2, 3, 4, and then Notice, okay, so right down here, I'm at 4.916666, right? And I think if I go down one more, oh, my calculator actually shows 5. And what's it show at 5? It doesn't exist. So that's why my 5 has parentheses, because 5 doesn't exist. It's not part of the domain. And then if I keep arrowing right, look what happens. It picks back up on the positive side of 5, doesn't it? And then you'll notice it keeps, we could trace forever. It's going to keep going on to infinity. Okay? I'm all about the algebra, but there is something to be said for being able to use the algebra and the graph together. Okay? They reinforce each other. And there's times, I'll be honest, we'll look at some equation, I may be like, you know what, let's just graph it, because the algebra just doesn't, it's not easy. So there's times we're just going to want to go straight to the graph. Okay. Questions I can answer there. Okay. I got to move it. Gosh, I'm talking too much. I got to speed this process up. Forgot we have 2 more domains. I thought we were ready to go into range. Okay. C. Okay. I'm going to ask. Third problem today, third time I'm asking. What are the 2 things we need to consider with domain? What causes problems with our x values? Square root and denominator. Now, I see a square root, but does this square root cause a problem? No, because there's no variable under the square root. Square root of 3 is just a number. That's fine. That's perfectly fine. We're talking, when I say square roots and denominators, we're talking about when is the variable in there, right? Okay, so there's no variable under the square root. Any variable in the denominator? No. Okay. If we are to graph this, we're going to get a parabola. Okay. We're going to get a parabola with a stretch or shrink there, something like that, because that's what the square root of 3 over 4 is doing. Okay. But this is a parabola. Okay. No square root issues, no denominator issues. So what's that mean about our domain? If there's no square root issues, no denominator issues, all real numbers. And if I even, you don't have to graph it, but if I graph it real quick for you, just as a sorry, my calculator's in slow motion. It does that sometimes. It just decides it wants to be slow. Okay. Think about it. It's a parabola, yes? What happens as my parabola goes out to the left or up to the left and right? It's also getting wider, yes? Does it ever stop getting wider?
No.
Officially, no. It's constantly getting wider. So officially, just looking at this equation, officially, we would say all reals, which how do you express all reals in interval notation? Negative infinity or positive infinity? Okay, because we could put any x value in this equation and it could work. Now, let me throw a what if at you. Notice this equation is not x's and y's, is it? It is s's and a's. This is the area of an equilateral triangle with side length s. Okay, so just look at the equation with no background. We can put in any s value we want. What if I tell you this is specifically the area of a triangle with side length s? Can we still put in any s value we want? How does that change things up? Yeah, can a triangle have a negative side length? Okay. And I don't remember necessarily seeing anything like this in homework, but, you know, we need to consider the situation. And the situation in this case is, okay, if this models the area of a triangle with side length s, s is going to have to be positive, isn't it? You can't have a side length negative. Can we have a side length of 0? Can the length of a triangle be 0? No. Because then again, the triangle ceases to exist, doesn't it? So, what I'm going to write down here is that I'm going to say, but this models the area of a triangle with side length S. And we just talked about if it has side length S, then S will have to be positive. It has to be greater than 0. And how do we express S greater than 0 in interval notation? Where does that start at? 0 to infinity. Infinity always uses parentheses. Do we want to include 0 here? No. So your official answer, based on the consideration that this is area of a triangle with side length S, is 0 to infinity. If this is just X's and Y's and you weren't told that, then yes, it is all real numbers. Okay? Okay, shall we try D? What kind of issues do you see with D? Square root and a denominator, okay? So, individual pieces here. What do you know about this square root? A square root must be positive. So what I always do is whatever's under the square root, I'm going to set it greater than or equal to 0. Okay, you can solve that, yes. X squared plus 5 greater than or equal to 0, we're going to subtract 5. X squared has to be greater than or equal to negative 5. What happens when you square any number? When you square a positive, you get a positive. What happens when you square a negative? You get a positive. So what do we know about x squared? X squared is always going to be positive, yes? And notice I'm not taking the square root in this situation because what happens if we try and take the square root of a negative? We can't do it, can we? Okay, and so this deal here is we checked the square root, but anything I put in for x squared is going to come up positive. And then if you have a positive number and you add 5 to it, aren't we always going to have a positive number here? Okay, so because it's going to be a positive, adding 5, it's always going to be positive. And so we checked this square root, but this square root isn't going to matter. It's not going to affect my domain. Okay, so I'm going to say this one is okay. Trying to decide what I want to write here. I'm going to say because x squared is always positive. Okay. Now, so this one, we don't have to worry about the square root. It's always going to be positive. What's the other thing I have to consider here? Okay, denominator cannot equal 0, so we're going to set the denominator equal 0. So that tells me x can't equal 0. So think about, what's that mean? If x can't equal 0, here's me trying to get you guys thinking about a number line. Here's 0. X cannot equal 0. Did we end up with any other restrictions? No other restrictions. So what's that mean? What can exist? Huh? Anything but 0, which means we can have numbers less than 0. We can have numbers greater than 0. We just can't have 0. So I use the old-fashioned whole there, right? But it's the same thing as having parentheses. Okay, putting this in interval notation. When we start the left end of the graph, where does this interval begin at? Negative infinity. And where does this interval go to? 0. So negative infinity to 0. Both of those with parentheses. Union. And then this next interval is 0 to infinity. Now, I'm going to graph this real quick. You can or can't. You don't necessarily have to graph it with me because I know I'm quickly running out of time and we need to talk about range. Gosh, I'm not graphing very quickly though. Okay, now think about this. The graph should exist everywhere but where? 0. Is that what's happening? Yeah, what is that 0? What do you guess is happening there? There's an asymptote. Good. Vocabulary word you've got to know. We talk about asymptotes a lot in pre-cal. But notice, if we start tracing over here, I mean, my graph is going to go infinitely off to the left. I can keep tracing. Watch those x values. They keep getting smaller and smaller over there. Now, as I watch my x values, they're going. I've got all these x values that exist. Even at negative 0.15, I'm still existing. Notice when x equals 0, what's it say? Y doesn't exist. That's that asymptote. And then over on the right side, notice my x values start existing again. And so that's how you can kind of look at the graph. Are you seeing how they work together? In other words, I guess what I'm trying to ask is, does our answer make sense with the graph? And you may get to the point where you can just look at the graph and not have to worry about the equation. But again, I like to use them together. Okay, we've got to talk about range real quick. As we talk about range, there's two different ways to talk about range. I'll be honest, more often than not, you're going to see me talking about the graph to talk about range. Okay? Officially, though, depending on the equation, in order to find range, notice it says the same rules apply for range as do domain, except instead of having our equation y equals, we're going to use our equation with x equals. And once you use the equation with x equals, you can use the same rules about square roots and denominators. Okay? Now, when we're talking range, we're talking what kind of values? Instead of x values, we're now talking about y values, right? When it was x values, I said, okay, we're going to take our graph and we're going to read it from left to right. How do y values read? Up and down, yes? So with y values, what I'm going to say is because we want to read from smallest to largest, we're going to read down to up. I know that doesn't really sound right, but we're going to read from the bottom of the graph to the top of the graph. That'd probably be a better way to put it, wouldn't it? Oh well. So we're going to read from the bottom of the graph to the top of the graph. Now, okay, note we're finding range here. Let's look at A real quick. Remember, f of x is the same as saying y equals 2 over x, right? How do I solve for x? If it's 2 divided by x, we want to multiply by x. And I just wrote the wrong thing. We're going to multiply by x. Keep going from there. Okay, so, and that's why this is doing it, isn't it? Okay, so, while we're waiting for the screen, we multiplied by x. X times y is xy. On the right, what happens? If you have 2 over x times x, which is x over 1, then we're going to have 2. To solve for x, we're going to divide by y. So we end up with the equation x equals 2 over y. And that's not what you'd graph, okay? That's not what I'm saying at all. But square roots, denominators. Do we have issues? There's a denominator, isn't there? What do we know about the denominator? A denominator cannot equal 0, just like up above. And so in this case, we solve for x. We got y in the denominator. Y cannot equal 0. Do we have any other issues? No. So how are we going to write the range if the only problem is that y cannot equal 0? In other words, think about your number line, right? We have 0 here. Y can't equal 0. It can be everything above and below. So still using interval notation, how do we write that? Negative infinity is my left interval going to 0, and then 0 to infinity. Now, I know I'm trying to rush, but I really want to talk about this last one real briefly. As you look at that last one, is it going to be easy to solve for x? Not in my opinion. And I'm the teacher, so if I'm saying, this is not going to be easy to solve for x. So, because it's not easy to solve for x, you know what I'm going to say we're going to do this? We're just going to graph it. We're going to graph this, and I'm going to say because not easy to solve for x. The other one was easy to solve for x. This one is not. And this is where I'm going to run out of time. What is it? X squared over x squared minus 1? Huh? What, the period?
No.
Or I have a few years experience on you guys. I can type them in pretty quickly. Oh, okay. Well, what we're going to have to look at, and I guess maybe we'll look tomorrow, but, we're going to look from bottom to top. The fact that this graph, it starts down here at the bottom. So it goes negative infinity. It's going to go up to 0 right there. And then we're going to find there's a horizontal asymptote at 1. So my y values are going to go 1 to positive infinity. Okay. We'll talk about range more tomorrow, like in homework and stuff. Do the homework, 2 through 20 evens, and we'll discuss it, okay? And I will definitely remind me to review this one some more tomorrow.
So I was able to find out a time that I could take it during the future.
Okay. Are you going to be ready for it?
Yeah.
Okay. If you're ready for it and want to do it tomorrow, that's fine. Otherwise, we can push it to next week if we have to. Okay.
If I need to study one more time during homework and then still do a third hour, either one works for me. But I've been reviewing.
Okay. It's either or with me.
I'm going to go to Mrs. Sexton, then I'm going to take my test, and then I'll be back.
Okay. Please do so. Yeah. Just a second.
Okay. Yeah, let's break numbers.
Okay, hold on, guys.
What do you mean, Hannah?
Hold on. My recording's still going. Okay, guys. So, real quick on this, y values read from bottom to top, negative infinity up to 0. This does touch 0, so I did negative infinity 0. Then we'll discover there's an asymptote here, which means it doesn't touch 1, but that asymptote's at 1, so 1 to infinity. And that is what we would list as our range. Homework, page 294, 2 through 20, evens.